Hi, welcome back. So in part one, we've seen the average dividend yield model and we've used it to value the Coca-Cola company. In part two, we'll implement the model in the code editor from scratch. So I'm going to bring up the source code, open in model editor, and we want to select a new model since we'll be making it from scratch. Going back to the spreadsheet, we're going to need data such as dividends, prices, and treasury yields. Let's open up a developer's guide and navigate to the API functions and endpoints. The annual dividends per share can be retrieved using the getDividendsAnnual function. Let's copy it and paste it into the arguments of the when function. Now we'll do the same to retrieve the quotes using the getPricesAnnual function. And for the treasury yields, we'll be using the getTreasuryAnnual function. So now we need to specify three response objects in the same order as the get functions. I'll put an underline as the first character to denote that this is a response object. These objects will contain the HTTP response of the get functions. Let's log these objects to the console to see how they look. We'll go ahead and delete the print hello world function and we'll write console.log dividends, prices, and treasury. And now I'll fill in the Coca-Cola ticker KO and run the code. To see the objects, we need to right-click, inspect, go to the console, and we can find the response objects in the console. To get rid of all other logs, we can press this little bin button to clean the console and run it once again. Let's take a look at our response objects. Click the little triangle to expand the first object. This is an HTTP response object with status success, and the retrieved data should be located in the first element. Let's expand it, and here we can find all the annualized dividends paid by Coca-Cola. To select the dividends element from the response object, we will use the deepCopy function. We can find this function in the developer's guide under valuation functions. In the JavaScript language, objects and arrays are mutable by default, and we don't want to alter the original response objects, as it can cause some caching issues in the watchlist and notifications page. We'll need a new variable that will store the copy. Notice that the new variable is declared using the var statement. So now let's go to our model and create our deep copies. Var dividend equal deep copy of the response object. Let's copy and paste this for prices and treasury. And delete these two. Let's also save our model to not lose any of our code. We'll name it average dividend yield model. Hit save. Now it should be in our custom models. Let's change the console logs to log the deep copies. Clear the console, input ticker KO and run it again. Notice we have 60 years of dividend data, 61 years of market prices, and 33 years of treasury yields. If we expand the dividends, the first element is the last 12 months, which is expected. However, if we expand the market prices, we can see that the last price was from yesterday. Also, the treasury yields were from the beginning of the year. So we can get the last price from the company's profile using the getProfile function from the API functions and endpoints. Let's add this. and the get treasury. Also write the response objects. And now create dip copies of them. Save our model. And let's also log the new objects to see how they look like. Clear the console and run it again. Let's expand the profile and look for the price property. We'll write its value to the first element of the prices object. The first element of prices dot close equals profile dot price. So now we've got the data to calculate the average dividend yield over a period of, say, 10 years by default. So we'll add a new input named historic years and set it to a static value of 10. Let's slice our data to the historic number of years we're setting in the input. With using the slice function, going from index 0 to input dot historic years. Let's do the same for prices and treasury. Now, if we clear the console and run it again, we can see that the lengths have changed to 10. If we open the console output and edit this number to 15 years, the length automatically updates. So now that we have our data sliced, we can begin to calculate the dividend yields. Let's get the last 12 months dividend. var LTM dividend equals dividends, first element dot, we'll expand the dividends object and get the last 12 months adjusted dividend. We'll do the same for the last price, equals to prices, first element dot close, and the last dividend yield will be equal to the last 12 months dividend divided by the last price. Let's print this yield using the print function. So print the value, last dividend yield, the label, and the percentage sign to indicate that this will be a rate. Clear the terminal and run it again. You can see the last dividend yield was 2.774%. The full documentation for the print function can be found in the developer's guide, Valuation Functions, Displaying Messages. Now, in order to get the average dividend yield, we need to calculate all dividend yields for the past historic years. Make an array named dividend yields list. That starts with the last dividend yield. Then we will use a for loop to go through all dividends. For var I in dividends, opening and closing braces to define the beginning and the end of the for loop. Now we'll need to match the dividend dates with the price dates to make sure we're not dividing values from different years. Let's expand the dividends and the prices, and we'll compare the years of the dividend with the date of the price. Let's write if dividends of index I dot year is equal to the prices of index I dot date. Notice the prices have full dates. We'll get the year using the getYear function. This function is also listed in the documentation in the dates functions. Let's get this period's price, or price equals prices index I dot close, and this period's dividend, var dividend equals dividends of I dot adjusted dividend, and calculate the dividend yield. It equals the dividend over the price. We'll add the dividend yield to our list using the push function. So dividend yields list dot push the dividend yield, and let's log the dividend yields list to the console. Clear the console, hit run again, and we can see all the dividend yields for the past 10 years displayed in the console. We'll now calculate the average dividend yield by adding up all the elements in the list. We'll use a special function named getArraySum, listed in the developer's guide, utility functions. GetArraySum of the list and divide it by the length of the list. Let's print this value. As a rate. Clear the console and hit run once again. We now have the average dividend yield calculated, so let's use it to calculate the fair value per share. Make a new variable named value per share equals to the last 12 months dividend over the average dividend yield. We'll also get the currency from the profile object. Expand the profile object and look for a converted currency. This is the currency of both dividends and prices and changes whenever another display currency is selected. Let's set the estimated value of the model using the setEstimatedValue function, which we can find in the developer's guide, setting estimated value. Copy the function, paste it here, fill in the arguments, the value per share and the currency. Save the model. Let's clear the console and run it again. To be able to see the estimated value, we'll need to click the drop down, opening company valuation. This will open the valuation model to Apple by default, but we can go ahead and search for Coca-Cola manually. And we can see the estimated value right at the top of the model. In the next video, we'll clean up the code a little bit to make it easier to follow and calculate an estimated value by using the surplus yield from the spreadsheet. So see you in the next video.